The next method that we're talking about is the difference and sum of cubes, which is more binomials, which means they're going to have a formula. So when you're factoring difference or sum of cubes, we need to remember some of these perfect cube facts. There's a whole lot less than the perfect square facts because cubes get really big really quickly. So these are the ones that come up an awful lot. 1 cubed is 1 times 1 times 1, or 1. 2 cubed is 2 times 2 times 2, or 8. 3 cubed, 3 times 3 times 3, that's 27. 4 cubed is 64. 5 cubed is 125. And 6 cubed is 216. So these numbers get awfully large awfully quickly, so these are probably the only ones that will come up an awful lot in your problems. Now I rewrote your formula so you didn't have to keep flipping back to the page before. So we have a cubed minus b cubed and a cubed plus b cubed, and we have their factorizations. Now I want you to notice how similar they are. We have a and b here, and a and b here. A squared, AB, and B squared. Notice every single term is exactly the same. Even in the original polynomial, a cubed and b cubed is the same. So what is not the same? So the only real differences look like in the signs. So there's differences in the original problem, and then there's differences here of my signs. So one easy way to memorize these two, more as like just memorizing one, is just to kind of get the signs down. Well, I have a neat little trick to get your signs correct. Once you have your terms correct, it's called SOAP. SOAP stands for same, opposite, and always positive. So whatever my first sign is, if it's negative, then my first sign is also going to be the same, which is negative. My second sign in the factorization is going to be O, opposite. So if my first sign is negative, then my second one's going to be positive. And then the last one is always positive. So does this work for the positive as well? Well, yes, same, positive, positive. O says opposite, so my original problem was positive, so then my second sign will be negative, and then AP stands for always positive. So this SOAP is going to help you get two formulas for the price of one. Now the only other thing you need to make sure you get down is the terms. So I know my first factor, a plus b or a minus b, is pretty easy. It's the a and the b from the a cubed and b cubed. Just take off the cubes basically, and then I'm not going to fill in my sign because those signs are going to be filled in with my SOAP. It's this trinomial over here with the three terms that gets a little confusing. A squared, ab, and b squared, and people kind of get those confused sometimes. So the way I like to teach it is, instead of thinking about a squared and memorizing it as a squared, I want you to think of it as a product, a times itself, a. This is going to help you first memorize it better, and secondly is going to avoid some negative errors that you might have made when you were trying to square something. It's also going to save you one line of work possibly in some of the problems. So I like thinking about it, instead of a squared, just think of it as a times a. So the last term is b squared. Well, that's just b times b. And then the middle term, that's a times b. So if you think of these as three different products, the first product is a times itself, the last product is b times itself, and the one in the middle is like a little compromise, one of each. You know, like if you think about the first terms like a's times a's are better, and the last term's like no, b's are better, and then they're like, okay, we'll come together in the middle, one of each, a times b, like a little compromise, okay? So that's kind of how I memorize it, and it's going to help you avoid errors later. So let's do some of these factor problems. On this first problem, we have x cubed plus 8. Well, I want to first identify what's being cubed on each one of these. Clearly on the first term, x is being cubed. It clearly says x cubed. But how can I rewrite 8 as a perfect cube? Well, if you look up in the list we just wrote, we know that 2 cubed is 8. So we have x being cubed and 2 being cubed. So x is my a term and 2 is my b term. We're not ever going to be using 8 again when I'm trying to factor. When I'm trying to do this, I like to kind of make two parentheses. One parenthesis a little bit longer than the other. The first one is a binomial, the second one is a trinomial, so I like to kind of put my blanks in there so I come back and fill them in. The first binomial is pretty easy. All you do is just take off the little cubes and these slide right in. The trinomial, which we said was a little harder, I want you to think of it as three products. My first term's product is going to be x times itself, x. My last term's product is going to be 2 times itself, 2. And then we're going to meet in the middle and just do one of each. So x times x is x squared. 2 times x, that's 2x. And then 2 times 2, that's just 4. Now that I have all my products in place, I'm going to come back with my SOAP. My SOAP says same, opposite, always positive. This original problem had a plus sign. So I'm going to put plus in for same, because that sign's got to be the same. What's the opposite of plus? Well, that's minus. And AP stands for always positive. So this is the factorization of my sum of cubes. So the next one's an example of a difference of cubes, but the way that we do it, we don't even think of it as sum or difference of cubes. It's basically the same formula, except you apply your SOAP. So my first thing I want to do is identify what's being cubed. So the first term, x is being cubed, that one was pretty simple. But what cube gets me 125? Well, that answer is 5. So 5 is the thing that's being cubed, 5 is my b, and x is my a. I'm not ever going to be using 125 when I'm plugging it in. I'm going to be using 5 into my formula. Then I make my little blanks. I make sure I have 2 blanks in the first parentheses and 3 blanks in the second parentheses. To get the binomial, I basically just take off the cubes and slide those terms right in, x and 5. To get my trinomial, I have an x times an x on the first one. On the last term, I have 5 times 5. And in the middle, I have one of each, like a little compromise there. So I have x times x, or x squared. 5 times x is 5x. And 5 times 5 is 25. Then I go back and use my SOAP. Same is minus. My problem had a minus in it, so same is minus. Opposite is positive, and always positive is positive. So this is my final factorization. One thing students might mention is, can't this factor some more? Well, first of all, I haven't taught you how to factor any trinomials just yet, but this can't factor anymore. If it would have factored more, it would have factored more up here in the formula, and because it didn't factor up here in the formula, you know you're good. You don't have to keep trying to factor that further ever. So 125x cubed minus 27y cubed. 125x, well, that's 5x being cubed. 27, that's 3y being cubed, so 5x is going to be my a and 3y is going to be my b. When I factor, I want to have a binomial and a trinomial. On the binomial, the 5x and the 3y just slide in. On the trinomial, I have to take 5x times itself 5x for the first term, 3y times itself 3y on the second term, and in the middle I have one of each. So 5x times 5x is 25x squared. 5x times 3y is 15xy, and then 3y times 3y is 9y squared. I'm going to come back and use my SOAP. My first sign was minus, so the same would be minus. The second sign says opposite, so it's positive, and always positive, well, that's always positive. And when you use these products here, you're also saving yourself a little bit of time, because if you went straight for the formula says a squared plus ab plus b squared. Look at all those parentheses inside of another set of parentheses. First of all, that gets students confused. Secondly, you'd have to do a whole nother step, because 5x squared, you can't leave it that way. You'd have to write 25x squared. And then sometimes students forget to distribute that correctly. So doing it the way I taught you with this 5x and 5x times 5x and 3y times 3y and 1 in the middle saves you this whole extra line of work that you can go straight to the answer without actually having to write that out 2 or 3 times to try to distribute and possibly make some errors. So doing it the way I taught you actually saves you a little bit of time. The other thing students might mention right about now is that this last term has a squared on it. Whereas if you scroll up and look at the other two don't have squares on them. And sometimes I'll have students come back to me the next day and be like, okay, some of mine have squares on it and other ones do not. Can you think about why the first two problems didn't have squares on the last term and this one does? Well, the reason here is because this last term has a variable on it, 3y times 3y. Well, 3 times 3 is 9. I got that 9 part. But y times y, I don't know what y is. It's a variable, so therefore the only way to square a variable is to write y squared. Up on the other two, I had 2 times 2. That's actually just plain 4. I didn't have a variable, so it doesn't have a squared. That's usually one question I get, so I like to kind of teach you that before you get too into the problems and get frustrated about why that doesn't have a squared, or sometimes it does. On my next problem, 40x cubed plus 135y cubed, 40 and 135 are not on my list of perfect cubes. So that is a good indicator that I'm going to have a GCF. 40 and 135 can both be divided by 5. When I take out the GCF of 5, I'm getting 8x cubed. 8 is my perfect cube list. Plus 27y cubed. Again, 27 is in my perfect cube list. So when I try to factor this, I know I have a binomial and a trinomial, but please don't forget to bring down your 5. 5 is a GCF. It's part of the factorization, but a lot of students will factor the GCF of 5 out, but then forget to write in the answer, and then that's wrong. So on this first term, I have 2x being cubed to get 8x cubed, and for 27, I have 3y being cubed. So the first binomial factor is pretty easy. I just take off the cubes and the 2x and the 3y slip in. On my binomial, I have 2x times itself 2x for the first term, 3y times itself 3y for the last term, and then one of each in the middle, which gets me 4x squared, 6xy, and 9y squared. I'm going to go back and use my SOAP. My signs are the same, so that's positive. Opposite meaning minus, and always positive is plus. So this is my final factorization, and there's no more factoring to be done here. On my next problem, I have 4 terms. This is not like the other problems. This is 4 terms, not a binomial, so this is grouping. So initially I have to look at this problem as a grouping problem. I'm going to group it in first 2 in blue and the second 2 in red. On my first group I can factor out a y cubed, and that leaves me with y minus 2. In my red group I have a negative in front, so that's going to factor out a negative. GCF of 64, which leaves me with positive y, because negative 64y divided by negative 64 is positive 1y, and positive 128 divided by negative 64 is negative 2. Are my two parentheses the same? Well, sure they are, so I factor that out, which leaves me with, in my second parentheses, y cubed minus 64. Okay. So that is a grouping problem. But notice in my answer I have a cube minusing another perfect cube. So y cubed minus 64 is a difference of cubes, which is why it belongs in this set of problems. So on my second factor is going to factor into a binomial and a trinomial. I have y being cubed minus 4 being cubed. So y and 4 are in the binomial. Y times itself, that's y squared. 4 times itself, that's 16. And 4y fits in the middle. Then I do my signs, same, opposite, always positive, and now I am completely factored. I don't ever have to worry about factoring that trinomial, because if it would have factored, it would have factored in the formula. I have another 4-term polynomial for the next problem, which means I'm going to have to do grouping. So when I do grouping here, I have 12 and 75, looks like a GCF of 3. Between x to the 5th and x cubed, that's x cubed y, which leaves me with 4 x squared minus 25. In my red group, it looks like I can factor out a negative 3 x y cubed, which leaves me with positive 4 x squared. Positive 75 divided by negative 3, that's a negative 25. Xy cubed divided by xy cubed is 1, and then I don't need to write it. So looking at my two groups, my blue group and my red group, I have a GCF of, let's see, it looks like 3. I have a common term of x, and I have a common term of y. I also have a common factor of the parentheses, 4x squared minus 25. So then in my blue group, I have leftovers, let's see, 3 divided by 3 is 1. X cubed y divided by xy is just x squared. And then my parentheses divided by the parentheses is just 1. Again, I don't need to write it. And then in my red group, a negative 3xy cubed divided by positive 3xy is a negative 1y. I don't need to write the y. The 1 because I already have the y squared here. The 4x squared minus 25 divided by the 4x squared minus 25, that's just 1. So it looks like I'm completely factored using my grouping skills. But before I box my answer and I'm done, I would need to look to make sure there's nothing else that can factor. Well, the second factor, 4x squared minus 25, that can break down into a difference of squares. That's 2x plus 5 and 2x minus 5. The 3xy, it can't factor anymore, so it stays there. And it looks like the last term is also another difference of squares. So that's going to break up into x plus y and x minus y. So although this problem started out to be a grouping problem, it turned out to also have two difference of squares in the problem, which made it have 5 factors in its prime factorization.